All right, class. Hello, welcome. Math 1342, Statistics. I'm going to be recording sections 1.1 and 1.2, and I will make those available as Zoom videos and put those videos inside our Canvas course. And they'll be located within the module that concerns quiz number 1 material. Okay, and so welcome to the course. My name is Dr. Gloria Guerra, and I'll be serving as your statistics instructor for the semester. So welcome to the course. Um, and so the Zoom video, now that the college has purchased Zoom, the Zoom video is to complement my saved past PDF lecture notes that I have available for students. And so the video is to complement those lecture notes that are in your Canvas course. Okay, and so what I've done is I've printed the workbook that you can print from your syllabus, your Concourse syllabus, and so you want to. This is concerning the 1342 course. Sometimes students are required to take a Math 0342, a co-requisite course, and that would be in a separate Zoom lecture. Like for that course, the first week they go over rounding whole numbers, and so that would have to be in a separate video available to the student, made available to the student in that Canvas course, which is something like Math 0342. Okay, but today this recording is for sections 1.1 and 1.2 of related to the quiz 1 for statistics. Okay, so I hope that makes sense. And what I have here is I have a printout of the workbook. Um, and these formulas here, you want to keep these handy and put them like on a paper clip, because these will be uh, utilized like for the final exam. So when we take the final exam, you are allowed to have these formulas out during the final. And so I have 1, 2, 3 formula sheets. And really, though, you notice the formulas start with chapter 3, and that's when we take our first test. The first test starts with chapter 3. And so just keep that in mind, that this is helpful for starting with chapter 3. You just put those over here on the side. And then this is I make use of the TI-84, and that's what that's what our department, engineering and mathematics department, makes use of the TI 84. And so we've always made use of the TI 84. And so just make a reference to that. And so this is what my calculator looks like, TI 84 plus. And this is what I'll be making use of for the semester. So that's why you were encouraged to purchase your TI 84 plus. And due to COVID-19, for the first time, the department has agreed to allow the app for the TI-84 plus, and it's related to the COVID-19 situation and requiring physical distance. And so normally the students are required to purchase a TI-84. So this is actually pretty much brand new because of the situation. Okay. And so, but this is what I'll be making use of as my TI-84 plus calculator. Okay. And so let me just put this over here on the side also. See? And then these you want to keep these handy also, like maybe staple them, but these are also TI-84 commands. um, and so um, we won't be needing these today, but certainly when we start, definitely chapter 3 and possibly some in chapter 2, but definitely chapter 3 and so on. And so keep these maybe stapled or on a paper clip, and because these are all related to TI-84 commands, so that would be helpful. So maybe keep those stapled or on a paper clip, okay? And then these are tables that we will also be making use of um, pretty much in chapter 6. So the standard normal table, okay? And we have the T distribution, binomial distribution. So some of these we show you both ways. Some of these we show you on a table, and then we also show you on a calculator how to use the commands for those. But again, you want to have the tables, kind of stapled together. That would be helpful. And then the chi-square distribution, okay? So just keep those handy, and there's a lot of material. And then you'll notice that today I'm going to go over 1.1. Then you'll notice page 1 is what I'm going to go over and cover today, all right? At 1.1 and 1.2. So this is on page 1 of your workbook, okay? And so the cover kind of, let's see. Yeah, so now in order to prepare for your quiz, I sent out an email about printing a quiz one, like a little study guide or review guide for your quiz, and then also a template. When you take the quiz, you'll be required to show your work on a template, okay? And so I have like an idea, a copy of the study guide here, so I can make this larger. And so your quizzes will be in Connect Math, okay? And they will, like quiz 1, which is worth 5% of the grade and has 14 problems and about 40 minutes to take that, will be in your Connect Math. And so these are the ideas or the topics that will be on your quiz, okay? Now I am looking into because Connect Math does not have a lockdown browser. I am looking at creating the quiz right now for the online students. I am looking at putting that in a Canvas quiz, and for the um, let's see, for the face-to-face students, we would be doing that in class, taking that in class, okay, for the face-to-face students, and for the online students that would be involved in the online classes that would be like in the Canvas quizzes. And so I'll just give you more detail about that in emails for the sections, but the content will be concerning these ideas from these 14 problems, okay? And so you are required to decorate this sheet. So you want to put, as you study, read your ebook, and as I go through these examples, you are allowed to use one sheet on during your quiz to help you and guide you during the time quiz. And so I recommend that you just decorate this and put some examples here, and also you can do that on the back. It's free. It's a free space on the back, and it is a requirement if students do not submit their I call it a cheat sheet or a toolkit, but if students do not participate in that and they do not submit that at the time that they submit their quiz template where their work is at, then there is like a 10-point deduction for that non-participation off the end score of the quiz. So make sure you are creating your study guide, and you can use that while you take the quiz. And it can be, any examples or any calculator commands or any notes that you think will help you on the time quiz. Okay. And so, for example, one of the questions will be the definition of statistics. So, of course, we recommend that you write down the definition of statistics here on your paper, for example. When you do, like, for example, the problems determine if it's descriptive or inferential statistics. On your template, you're prompted on the template, you are asked to write down the specific question that the computer generates for you, and that's part of showing your work. And so, whatever question is generated for you, you are required to write that down and share that on your template with me when you upload your template. So that's part of showing your work. So there is a 1 point deduction for that if you do not write down the question associated or assigned to you. Okay, so you do have to let me know what a question the computer decided to give you, and you want to jot that down on your template. So that's part of showing your work. The one that involves like actual calculation will be this last one here, like when you're working to find boundaries. This is the one that will require some calculation. And so, yes, you on the quiz, you input your answer and you type that in. But then I go back and look at your template, and you do have to show me the work. How did you get that answer? So you have to, your when you have calculation type problems, I don't just check correct answers. I also go back and double check your work, and your work has to support your answer choices, okay, for the full credit on that. Okay, so just keep that in mind. So put that over here. Okay, and then so I'll go ahead and start now with some of the ideas here for 1.1. Okay, so let me get my notes out for that. Let's see. So the first problem, or the first page one, it talks about, it's titled Descriptive and Inferential Statistics. Okay, and you saw from your quiz that you're going to have two problems like this, and when they give you the question, you'll write that down, and you want to determine if it's descriptive or inferential. And the thing is that the computer gives you two problems, but it randomly generates it, so you're not sure if you're going to get two descriptive, or you're going to get two that are inferential, or you might get one of each. So you have no way of knowing, because the computer just randomly pulls from that set. And so just let your definitions guide you when you decide on that, because you just don't know what the computer's going to pull. But it will give you two problems concerning those ideas of descriptive or inferential. But before we get to that, that definition of descriptive and inferential doesn't actually start, I believe, until page 2, I believe. Yes, page 2 is where that starts. So, but I do have to go over just some other definitions here. It's like, oh, for example, statistics. You know, your quiz, your very first problem on your quiz is going to concern the definition of statistics, which is the science of conducting studies to collect, organize, to summarize, to analyze, and to draw conclusions from data. And so on the quiz, some of these will be like either fill in the blank or multiple choice, and you just don't know which words, right, will the computer prompt, and it will be, different words for different students as it generates the variation of the problem. But you definitely want to have the definition of statistics on your paper, so that you'll be able to decide what's needed to be chosen to fill that in. Okay. And then this question, why study statistics? Well, they say it's to gain knowledge about seemingly haphazard situations. Statisticians collect info for variables which describe the situation at hand. And then they say, here are some examples of industries or businesses that use statistics. So yeah, so, local companies like, Walmart, HEB, okay. So hopefully you're able to use curbside for serve those stores. Um, the UT Health Science Center, for example, USAA. So these are all local towns. But yeah, most most large um, industries, businesses, they do pay statisticians so that they can, be safe. I have to say, be aware of situations to have the environment be a safe environment, or also to improve business, right? To improve the environment around them in the store, in their stores. Okay, a variable is a characteristic or attribute that can assume different values. Okay, so I'm going to note that a variable can also be called, a data item. Okay, and then some examples. Also, I'm going to say that a variable, that a variable can be also counted or measured. Okay, and as far as examples, I have age is one, gender, and I also have business income. Okay. Um, and then I also went ahead and put types of variables here. And later in this chapter, we will talk about these words that I'm going to write down. But for now, I have types of variables. We could have like numeric variables or continuous variables or discrete variables or categorical variables, ordinal variables, nominal variables. Okay, so I just put those down as just for types of variables. Okay, we'll go over those more in detail in this chapter 1. And then we have here that the values that a variable can assume are called data. Okay, so data is defined as, facts or pieces of information. And there were some examples here. Uh, Data could be, collecting heights of people, collecting ages of people. So height, age, number of children. Okay. So there's many things we can jot down for data, but there's just some examples there. Okay. Um, and then here we have a collection of data forms a data set. So each value in the data set is called a data value or a datum. Okay. And then so here we have some examples of a couple of names mentioned here, and their heights are provided, and their ages are provided, their marital status are provided here. Okay. So we look at the next page. Okay, let's do that. Page 2. So we have a population. So the population consists of all subjects, either human or otherwise, that are studied. When data are collected from every subject in the population, it's called a census. Okay, and by the way, the census is taking place right now, and so if you haven't had a chance to participate in that, it would be very helpful because the state is able to gain monies from the contributions of the people who live in the state for participating in the census, and you can provide monies that will help improve our situations like our roads and things like that. And then also it has to do, it also affects like our electoral, right? With voting and things like that. It also votes increases our number of representatives based on the size of our census population. And so if you haven't had a chance to participate in that, please do that. Okay. And that occurs like every 10 years, right, for the census. Um, it says here that it is not the norm to do statistics on populations, okay? And instead what we do is we use samples. So I'm gonna write that down. Instead. Okay. And the reason is that the reason why we use samples and not in the entire population is because it's not cost effective. It would be just too expensive to test every single person in the population. And there's not enough time to do all of that to capture each individual. Population in most cases is very large, too large, and there could be some maybe some possible medical concerns related to that also. But it's not the norm to do statistics on population, so we make use of samples instead. So that's why we have here a sample is a subset of the population. So you have a nice picture here from your book of this sample being a subset of the population. If the subjects of a sample are properly selected, most of the time they should possess the same or similar characteristics as the subjects in the population. And and that's why, your subjects should be chosen also randomly. That's very important. One must strive to avoid biases, which will be discussed in 1.3. But that's the importance of choosing subjects randomly. So it says, um, what do you what do you do uh, once you have collected the data? Okay, and it says this is where section 1.2 comes into play. Okay, and I will go over 1.2 in the same recording. Okay, so we'll talk about that in 1.2. Um, there are two main areas of statistics, okay, descriptive and inferential. Okay, so with the descriptive consists of the collection, the organization, the summarization, and the presentation of your data, okay, which is important. That's one of your main definitions, okay. And then they have here um, describe a situation, okay. So it says you have taken the time, or you have taken the given date, and you are describing aspects of that particular date, and that we're not making any kind of generalizations. Yeah, because if you make, the reason why they say that is because if you make a generalization, then that would be more of an inferential statement. And so that's why they say that here. And so you have lots of information, you have lots of ages here, and years, you have years listed here. um, and then you also have a chart, and these are really small, but they look like they have ages. I see up to 50 plus. Okay, and so a lot of times with descriptive, you can create charts and things like that for presentations. And this looks like it's related to a fall 2012 data for St. Philip's College. Here's what they have as information that's there. Okay. They also have some other bar bar graphs, or I see some frequencies listed here, some line graphs listed here in this next page here. Okay. And they have this looks like it's first time in college enrollment trends. Okay, so they have some years from 2004 to 2012, And then they have a nice set of lines. You're able to distinguish first time in college, continuing, others, transfers. Okay, so these are examples of things that were created to help with the presentation of your data. So like the presentation of the data. So you can see here, descriptive statistics consist of presentations of data. So they have these charts here. They've got a histogram. We will later on in the course be showing you how to make box plots. I think that's probably 2.4, I think, but we will be showing you how to make box plots on the calculator. They have some pie charts, some bar charts, okay, and um, and then that's really all they have here as far as descriptive goes, okay. Um, I'm going to put a few comments here because I have space before I go into inferential at the bottom. And so I put just a few ideas here about descriptive. So this is just a statement that would be considered descriptive as opposed to descriptive or inferential. If I say that, make a statement and I say that the U.S. government reports the population of the U.S. was the size, look, 179 100,000 million, 179,323,000. And this was back in the 1960s. Okay. So that would be an example of a statement, right, that would be considered more descriptive as opposed to inferential. But if we were going to use that kind of information to try and estimating future populations, then it would become inferential. So estimating to use such data, okay, and you might have several facts, several statements, but if you start trying to use the data, to use such data to estimate future populations, makes the content become inferential. And then I'll show you that in a little bit when I read the definition, which is towards the bottom, about whenever you're trying to make estimations or some kind of a futuristic estimation or a future goal, then it becomes more of inferential when you use data to make estimations about the future. So that's a key word there, you know, future and inferential, okay? Future estimates, okay? I'm going to write down another statement here that's an example of just descriptive. And that would say that they're saying by the Bureau of Labor Stats, they're making a claim that the average hourly earnings of construction workers so the earnings oops, sorry. So the earnings, right, were, and they make the statement that they were $20.60, and this was for back in February of 2000. And it looks like it was 2007. Looks like that was 2007. Okay. So that would be a statement that would be considered uh, descriptive. Okay. So this department would have all the information that they would need to go back and look at, all the construction workers, and all of their earnings, right? And then they would sum that up, all their earnings, and then divide by how many workers they had, and they would be able to come up with this computation of, they say, $20.60 for this hourly, the average hourly earning for this group, right? The construction workers. And so that would be an example of something descriptive. And they are doing like a calculation on that because they have everything they need to look at that and could come up with a calculation for that. That is an example of descriptive. Okay, so I'm doing something like that. Um, okay, and then at the bottom of the workbook, it has some information about inferential. So at the bottom, it says that it's down here at the bottom. So I'm gonna read that, but some of you might still be writing. So I'll leave it like this, but then I'm gonna read what it says about inferential. So inferential statistics consists of generalizing from samples to populations, okay? And so you're performing estimations, and they even say you can do hypothesis testing. You can determine relationships among the variables, and then also you can make predictions. So if you see any of that going on in your statements, that is more towards inferential. And so the first bulleted item they have here is you're generalizing from samples to populations. And then that's what a lot of times, if you want to read more about descriptive and inferential, you can always do a Google search and put differential and you can put descriptive and inferential statistics to look at other examples. But oftentimes they will emphasize with inferential that, remember, you're working with samples. You're working with taking samples. If you're taking samples, and then you're making a generalization about a population from the sample, that is going to be inferential statistics. So just keep that in mind. And then oftentimes they'll say that it's like inferential statistics. They'll say, like, sum it up and say that it's like a best guess of a population value based on sample information. Okay, so it's like a best guess about a population, right? Based on some kind of sample information. So just keep that in mind. Okay. Let's see. And then on the next page, you have a few more bulleted items concerning inferential. So you see this is determines the probability of characteristics of the population based on the characteristics of the sample, estimations, um, assessing relationships between the variables, and then testing claims. So that's like the hypothesis testing part. And it says to do inferential statistics, you have to be able to use probability, and that's one of our tests. Chapter 4, that's test number 2. Okay. All right. So then, let's see. And that's what our workbook has on those 2 vocabulary words, and then you of course can read in your ebook what their ebook has in your Connect Math. It's at the top, and then at the top is your ebook, and you would click on that, open that up, and go to chapter 1. And then of course, if you wanted more examples, you could always do a Google search and then just put descriptive or inferential and then read about that. You could also do YouTube descriptive or inferential YouTube videos, and then you'll have some things pop up about that. But now your workbook has a few examples, and it says determine if it's descriptive or inferential. So when you take your quiz, you want to show your work. When you take your quiz, Connect Math quiz, you're going to have 2 problems concerning that. So you have to write down your statement on your template. And these are kind of what the idea of what the statements would be. So everybody's going to randomly be given a couple 2 problems, and so you're going to randomly get assigned a statement, and you need to reveal that to me on your template as to what the computer chose for you. Okay, and so you want to write down that statement. So the first one says that the average jackpot for the top 5 lottery winners was 367 and 6/10 million dollars. Okay, and so this would be an example of descriptive, okay? And I'm going to say that it's because that it's an average that's based on data obtained from 5 lottery winners at the time. So they didn't give me a year, but at the time they calculated that. So we're able to do like a calculation on this. If we were to come up with this value, um, let's just suppose an example of that. Let's just suppose that the 5 top lottery winners, let's say that somebody won $359 million, and let's say that somebody won $325 million. And let's say that somebody won $385 million, and somebody won $369 million, and let's say somebody won $400 million. And so you would like 1, 2, 3, 4, 5. So you have the top 5 lottery winners. So you would add that up and then divide by 5. And so I'm going to show you that on my calculator. If I were to do that here, clear this out. So if I have open parentheses, which is above see right here, open parentheses above the 8 and the 9. So if I do open parentheses and then I type these 359 plus 325 plus 385 plus 369 plus 400, then I close the parentheses, and then I divide it by 5, and then I hit enter. So I hit divided by the 5, and then I hit enter, and that gives me 367.6, for example, which is kind of related to that. Okay, so I just uh, uh, thought out, thought out examples of these are not, this is not the only scenario, but I just thought of, if I had this information, this data, what might it look like? And so it would look like me knowing the five top lottery winners. So I just suppose that these are the winners. I add them up, divide by five, and then that gives me the what that average was. Okay, but you see, you would have all the data that you needed based on this statement. You would have all the data that you needed to compute that, and because you're able to do this computation, you're able to do a computation on it that leans more towards descriptive. Okay, and so we uh, we would be able to do a calculation. Okay, and that's kind of what helps us with leaning towards descriptive for this information, for this problem. And then the next one says that a study done by the American Academy of Neurology suggests that older people who had a high caloric diet more than doubled their risk of memory loss. Okay, so they're eating probably too many carbs, right? Probably too much pasta, too much bread, and probably not doing enough, maybe enough exercise, right? And walking that off in their bloodstream. And then they're noticing they're having some issues with the memory loss, right? They're noticing that. So high calorie diets, and then they're noticing, uh-oh, this idea of, this memory loss. So this is an example of inferential. And it's leaning more towards, I have the sheet over here. It's leaning more towards because of we're creating these relationships between the variables, okay? And so inferential, I'm going to say that we have a relationship, and this uh, generalization, or this is, I should say, this is a generalization. This is a generalization made from a sample to a population. So this is a generalization made from a sample to a population. Okay, and the population would be who? That of the older folk, the older people. That's your population here. Okay, and so the relationship is that the the high caloric diet, and then this memory loss associated with that. Okay, so that would be an example of inferential. Okay, all right. Yeah, and those are like your variables, right? Your variables, the high caloric diet, and then the memory loss. So those are like your variables. Okay, if you look at the next statement, it says that based on a survey of 9,317 consumers done by the National Retail Federation, the average amount that consumers spent on Valentine's Day in 2011 was $116. Okay, and so here, this is an example of descriptive. Okay, and again, the reason why it's more like it's an average based on a sample of 9,317 respondents. And this was back in 2011. So here we can do a calculation. So this kind of like what I did at the top with the lottery winners. This is similar to like what we did with the lottery winners. Based on this information, we would have all the data we needed to compute this 116, and so you've got um, uh, this survey of this many people, consumers. And so what you could do is, like, let's say the first consumer, it says consumers. So the first consumer one, let's say that person spent $85. Okay. And then let's go dot dot dot. So I know you have like 9,317 of them. So let's say consumer 9,000. Okay, let's say that one spent $100. Okay, and then plus dot dot dot. Then you go to the last consumer. Let's say the 9,317 consumer. Let's say that person reported that they spent $108. So then technically you would add all of those up, all those 85 and the 100 and the 108, and you would add all those values up for all those respondents, which are 9,317, and then you divide by 9,317, and then that would give you an equal, that would give you the $116. Okay. And so you would, based on this statement, you would have all the information that you're not missing anything. You're not missing anything. If you were missing some important data and it wouldn't allow you to compute the calculation because you're missing the data, then you would have to lean more towards the inferential. But here you've got everything you need based on this statement. You have these lists of consumers, and they responded to what they spent, and so that's why we've got that at 116. Then they add them all, divide by that, gives us 116. So that's descriptive. Okay, the next problem says that based on the current economy, 49% of the 18 to 34-year-olds have taken a job to pay their bills. And so this one, you can see here, this one is considered inferential. And so this is because this is considered a generalization. A generalization is made about the population. So generalization is made about the population, and our population is that of the 18 to 34-year-olds. And this is based on this, 49 out of 100 sample data. Okay, and so yeah, and the reason why I say that 49 out of 100 is because percent, the definition of percent, you see we have the percent symbol here. Remember, this is percent. Remember what percent means. Percent means parts per 100. So when someone says 49%, it's like 49 out of 100, right? So 49%, 49 out of 100 of all those 18, right, to 34-year-olds have taken this job. And so this is a generalization. It's made about the population, and you're taking it from a sample. Okay, this sample that we're using. So remember, when you're taking samples and you're making generalizations about a population, then that's going to tend to be inferential. Okay. Um, and then on the next one, it looks like we typed the same thing twice, but the next one says that in 2011 there were 34 deaths from the avian flu. Yeah, so that's like a fact, right? This statement, this fact that's made. This is considered descriptive. Okay, and this is like a summary. Okay, so detail detail is presented about a part, which would be that 34, right? Those who actually died of the avian flu, a part 34 of the total population with avian flu. Okay, so you think you've heard of that before, part over whole, part over four, whole. So we have this part, like the 34 deaths, right? But then the the whole part, like the denominator, is like the number of people with the actual avian flu, right? So you got all these group of people that would have the flu, and not everyone's going to die from the avian flu, and they're noting that 34 of them did. But this is the summary of like a fact they're making, a detail. So this would be considered descriptive, okay? And then this next one, in 2011, 79% of US adults use the internet. So this one is similar. These are similar. This one is similar to this one. Those are similar because they both have a percentage, right? A percentage of the population, and so the reason would be very similar. So you want to start like doing enough practice problems to start having a pattern and say, oh yeah, that's where, when I'm just given a percentage about a population, then that's going to be inferential. See, it's inferential. And so a generalization is made about US adults and the internet. Okay. Okay, and then this next problem says that in an online survey of 500 Virginia Tech students between the spring 2010 and the spring 2011, so that's like a whole year, right? 31% said that they had missed class because of alcohol consumption. Okay, so now notice here, you have a little bit more information than just the percentage. You have your base of 500 tech students on this survey. 500 tech students is survey, and 31% of them said this. So you see that's 31% is 0.31. You move your decimal over 2 places to the left, right? So 31%, the decimal is right here, and you move it 2 places over, so it gives you 0.31. So if I do a little math on that, I am able to do math on that. 500, a calculation, times 0.31. That means we know that 155 people said this. 155 people, or in this case, students, said this. And remember what they said? They said that um, because they missed class, they said because of alcohol consumption. Okay, so that's unfortunate, right? Unfortunate, because alcohol can do a lot of damage to one's organs, right, over time. That's unfortunate. Um, and so, but this is an example because we can do a calculation on this one. Because we can do a calculation, this is an example of descriptive. Okay. Because you see the previous one before that had a percentage also, but that was it. You didn't have your base. You couldn't do a calculation on that. So that lent itself to a generalization inferential. But this one, you have not only the percentage, but you've got the base that made this comment. And so you can do a little calculation on that. This would be more than lends itself towards descriptive. Okay. All right. Okay, so those are my notes for 1.1 in the workbook, and now I'm going to do my notes for 1.2. So 1.2, and then let me go back and look at, let's see, let me look at your quiz guide. Where did I put your quiz guide at? Let's see. So you can see these two were 1.1. And now we're going into 1.2. So this is 1.1. This is 1.1. This is going to be 1.2. Determine whether the data are qualitative or quantitative. And again, the computer is going to give you two problems like this. So when you get your statements, you want to remember to write down your statement on your template. And again, you're going to get two problems like this. You don't know, the computer's going to randomly generate problems. So you don't know if you're going to get two qualitative or two quantitative or one of each. It just randomly selects that. So just keep that in mind. So it talks about a variable. Okay, so we have it's a characteristic or an attribute that can assume different values. We have random variables whose values are determined by chance. Qualitative variables. Okay, so that's what we need. They want to know if we have uh, qualitative or quantitative. Okay, so qualitative, they say uh, variables that have distinct categories according to some characteristic or some attribute. Okay, and then they have then look what they have for quantitative variables. Quantitative variables are variables that can be counted or variables that can be measured. Okay, um, and so those are two ideas or definitions there. And then you have this flow chart here. So I'm going to put the examples. I see it says they're examples. I'm going to put the examples on the flow chart. So you start off having data, um, and then they have qualitative or quantitative, which is what they were talking about here, qualitative or quantitative. Okay, so what I'm also going to do is on the quantitative, I'm going to add to this definition. It's important to say variables that can be counted or measured using a tool, okay, or also ranked, okay. And so like for example, maybe you're also the idea of making use of a maybe making when you rank something, maybe you making use of a rubric, for example. So you can get some kind of a tally, right? Some kind of a tally, and you're ranking them, okay? And so for qualitative, examples of qualitative, I'm going to say just see flowchart. And this is considered a flowchart. So for qualitative, some examples could be like something like this, even putting a 1 and a 2, and did it fall under heads? Did it fall under tails? So you're just keeping track. Was it heads or was it tails, right? Also, brands of a PC, okay? So like, is it a Hewlett Packard or is it a Gateway, okay, computer? And so brands of PC. And then also I can put hair color, for example. Anything that involves color, okay? So like for example, hair color, okay? So you have redheads, right? Blonde, brunette. These are, for example, so this hair color idea. Um, and so remember we're doing qualitative. So variables that have distinct categories according to some characteristic or some attribute. Okay, so I'm also going to put gender, and I'm also going to put a religion. Okay, so like Catholic, uh, Presbyterian, Baptist, right? Um, I'm going to put one more. I'm going to put ice cream flavors. Okay, so vanilla, chocolate, strawberry. Okay, so those are ideas of these are example of qualitative variables, variables that have distinct categories according to some characteristic or some attribute. Okay, and then we have quantitative variables. Quantitative variables, so variables that can be counted or measured using some kind of a tool or that they're ranked. So I have examples here of like weight would be more considered a quantitative variable as opposed to a qualitative variable, because in order to compute one's weight, you need a weight scale, right? So you're using the tool of the weight scale to compute someone's weight. Um, Body temperature. So you would need a thermometer for to measure the body temperature. Okay. Or even we could put a balance in a checking account. Okay. All right. So those are examples of quantitative. Okay. And let's see, at the bottom, they want you to determine down here at the bottom if something is qualitative or quantitative. And let me just see what's on the other page. Is there vocabulary on the other page too? They do have they do have one statement here. Let's see, but this is a repeat. We saw this on the other page. Variables, quantitative variables that can be counted or measured. So actually I can scratch that out because we actually had that on the other page. And then I added that you'd have to have a tool, using a tool, for example, or that they're ranked. Okay, so let's see. So color, remember we talked about hair color, anything with color. So here's color of uniforms, of football uniforms. So you see, that would be an example more of qualitative because see, anything that has to do with color would be considered more qualitative as opposed to quantitative. Um, Pizza slices. So your pizza slices, they have small, medium, and large. So generally, on your pizza sizes, and you look at the diameter, right, of those pizzas, the diameter, that length there in the center. So pizza sizes, you have like a 10-inch or the 12-inch or the 14-inch is typical on your small, medium, and large. And this would be more of quantitative, okay? And this could be considered more of because like it's kind of like they said using a tool to measure or like ranked. So this is an idea of ranked 10-inch, 12-inch, 14-inch, right? Um, um, or even I guess your tools you could use like your size of your pan. You have the 10-inch, the 12-inch, and then the 14-inch still, right? And so, but this is more lends itself towards quantitative as opposed to qualitative. Okay, so it says numerical and it can be ranked. Okay, in this box here that we see up there, this little box that we have here. Okay. Genders of movie stars. Okay, well, they focused it on the movie stars. We had just put gender in general, see? But that would be an example of qualitative variable. And then ratings of teachers. So ratings of teachers, when you do like a ranking, a lot of times when you rate teachers, you do a survey, and maybe you might have something like 1 to 4, 1, 2, 3, 4. So maybe one being like a poor teacher, whereas 4 is like a excellent teacher, right? And then maybe I don't know, maybe 2 would be maybe what fair, maybe good, maybe I could put that. So one through 4. Okay. So then you would be able to rate your teacher. Um, and so, and sometimes they do that too, like with jalapenos, right? Give them a pepper or 2 peppers, right? Three jalapeno peppers. So you kind of seen that. They kind of do ratings. Okay. So when you do your end of the course surveys, there is some type of a scale, like a Likert scale that you rate them from like 1 to 4, for example. But that idea, that's more of quantitative. Okay, it's more like a ranking, right? And you have some values. You could do some measure. You could do some measures. You're using a tool. You see it counted or measured, and so you can do some measurements on the ratings of the teacher because you would be grading these numbers, and you could do some measurements on that. Okay. All right. Let's see. Um, Next page. Okay, so now discrete or continuous. Okay, so if I go back to the quiz study guide here, it does say here, be able to determine if the data are discrete or continuous. You'll have 2 problems like these will appear on your quiz. So this is still 1.2. This discrete or continuous, okay? All right, so for discrete, we have that um, discrete variables assume values that can be counted. Okay. Um, Examples are, okay, so I'm going to put also a keyword here. So values that can be counted. Okay, and the keyword is actually the number. They use the number in the problem. Okay. And when you're saying the values can be counted, we're saying the values can be counted like using like natural numbers, natural counting numbers. Okay. Like, you know, 1, 2, 3, and so on and so on. You won't see fractions or decimals in that. And when you count natural numbers, you're just using your fingers on your hand. 1, 2, 3, 4, 5. So counting natural numbers. So examples, we have the number of children, number of books, number of calls received by tech support. So you see how that I say that's a keyword. You see that here. Use my marker. The number, I consider that a keyword. So the number of children, the number of books, the number of calls. So I'm actually going to add the word of in here. The number of as a keyword. Okay. Whereas continuous, they say for continuous variables can assume an infinite number of values between any two specific values. Okay, so you see here on this example of recorded heights. Heights. Look at, you know, and if I do 72 divided by 12, see, 72 divided by 12. Yeah, is 6, right? So these are heights. So this is reflective of, right, of 6 feet. So then this would be 6 feet and 1, 72.1. So maybe, well, then you have 72.129. So yeah, so I was going to put 6 feet and 1 inch, but you can see how that's why they say the word infinite. Where was that? It can assume infinite number of values between any two specific values. Yeah, so on their heights, they're real precise on their measurements on their rulers. So they have 72.1, 72.129, 72.19. So those are examples of good examples of that, of the infinite number. Um, so they are obtained by measurements. So examples are height, weight, temperature, even arm span. Okay, so your arm span, right? Arm span. Okay, so because continuous data must be measured, answers must be rounded to nearest tenths, oftentimes the nearest whole unit, the nearest ounce, for example. Okay. Um, And for the students doing the correct part, because they use the word rounded, that's in the correct part of the lessons. They do start off with a lesson on rounding. I think it's rounding of whole numbers and then rounding of decimals, and also the concept of rounding up. So in the correct class, they do talk about that. That's one of the first things in their lessons that they do. Okay, and then it says as a result, we use boundaries for a given number. So that's what's coming up next. And that's down here, boundaries. Be able to give the boundaries for value of a continuous variable. Yeah, because see, these are coming from continuous variables. Um, and you'll have one problem like that on the quiz where you compute the boundary and you want to show your calculations, not just the answer. You put the answer in the computer, in the Connect Math, right, in the computer, but then you have to verify, show your work. How did you get those answers? And you show that on your template for full credit. And so I'll show you how to do the boundaries in a little bit. That's coming up towards the bottom in the next page. Um, but then it says, let's see, Uh, let's see. Let me go back. Right here where it says they are obtained by measurements, let me emphasize using a tool. Okay, whether it's a weight scale or some kind of a tool, some kind of apparatus, right, using a tool. Um, so when we test ourselves, classify each variable as discrete or continuous. Okay, so the highest speed of a hurricane. Okay, and so speaking of hurricanes, right? Just in time, we recently Louisiana was hit with Hurricane Laura, right? So we want to keep them in our thoughts, right? And during this difficult time, um, having to deal with a hurricane during this difficult time, so it's very concerning. But when we measure the highest wind speed of a hurricane, you would need some kind of an instrument to measure the wind speed. And because you need an instrument to do that measurement, um, this is a continuous variable as opposed to a discrete variable. Okay, and that would be because we need an instrument to measure this, which would be, this would be, you know, the wind speed, right? The weight of baggage on an airplane. Okay. Well, also, you know, when you've been to an airport, you put your luggage down on some kind of a weight scale, right? This would be an example of a continuous variable. Again, you need some kind of an instrument to measure the weight. So you need some kind of a weight scale, okay? So it's your instrument. The number of pages in a statistics book. Okay, where there's that keyword, number of, okay, in this case, we're talking about pages. You can count 1 page, 2 page, 3 page, 4 page. So this is going to be a discrete variable. So we can count using our counting numbers, starting with 1 and so on. Also, the next one, the amount of money. So even though it doesn't say the number, but amount is similar to number, right? So the amount of money, these are keywords that we talked about up here in the top in yellow. These are keywords. So that's also discrete. Okay, and then we say recorded values and boundaries. So the boundary of a number is a class in which a data value would be placed before the date, before the data value should be data, should be an A, before the data value was rounded. So for instance, they say 72.5 to 73.5 means all values up to but not including 73.5 for the number 73. But that's this is an example of a boundary. I see that it ends in 5. That's kind of a key there, that it ends in 5. So let me show you the next page. Excuse me. Sorry, excuse me. So let me show you how to calculate these. So your workbook your workbook has an explanation here, okay? And I'm also gonna put an explanation at the top because I want you to show your work and the calculation. So I'm gonna talk about how to show your work and the calculation at the top. And these are examples of, you have these variables, these recorded values. Like this would be given on your quiz problem. You would have this given value, like for length, for example, then you'd have to find the boundaries. Okay, but this just gives you the answer. It doesn't show you the work. You would type in your answer on the computer. Now I'm not sure on the computer if they give you the labeling or you also have to choose the labeling. But you know, that's labeling units is always important, especially if you're going into a medical field. You want to keep track of your units. So you can see different units here, the abbreviations for that, and then spelled out here. And so, but they don't have the calculation. That's where I'm going to show you. So at the top, I'm gonna do two things over here. Let's see. I'm going to say that the boundaries. The boundaries of a continuous variable are given in one additional place value beyond than how the data was presented. And then I'm going to highlight one additional place value. Okay, so the boundaries of a continuous variable are given in one additional place value beyond than how the data was presented. Okay, all right. And then, I'm going to show you exactly what that means beyond one additional place value in a little bit, but just to highlight that. I'm also going to put up here that boundaries always end with a digit 5. So boundaries always end with a digit 5. And we want to make use of subtraction, and you want to make use of addition on these. And then you're limited to the amount of possibilities that you'll have to subtract and add. So this is what we're limited to. Calculations for a boundary involve either subtracting and adding either the value 0.5, so 0.5 or 0.5. And so let me just be formal and put that in there. So let me just put 0.5 is the same thing as just 0.5. So minus or plus 0.5, minus or plus 0.5 or excuse me, 0.05. And actually, I'm being formal with the 0, but actually it might be better to less is more. So let me just put instead, let's see, minus or plus. Let me just put it as 0.5. Minus or plus 0.05. And then minus or plus, let me do this one here, minus or plus 0.005. Okay, so we have 0.5, 0.05, 0.005. Okay. And I don't think the book will give you anything beyond that. It usually those are one of the three values that you'll need to subtract and add to what they give you. Okay. Okay. So let's show you the work behind this here. Okay. So like the first one, 15, that's like a counting number. And this 5 is like in the ones place value. So when we say over here that when you're creating your boundaries, and you're working with one additional place value beyond than how the data was presented, so one decimal place value beyond this beyond this ones place would be tens. So for this problem of these choices, you would want to work with 0.5 because that's one decimal place beyond what you started with, which basically this is, you don't see the decimal, but basically the decimal is hidden right there, 15. And one decimal place beyond that would be this 0.5, the tenths place. So you want to subtract and add to 15. So you want to say that's 15 minus 0.5. And then you want to say 15 plus 0.5. Okay, yeah, so if I show you that, 15 minus 0.5 is 14.5. See, that's what they have right here. And then 15 plus 0.5 is 15.5. See, that's this right here. Okay. So on your quiz, you'll have to show me this calculation on your template, and then you write down your answer in your paper, and you type in this answer, on the computer, for example. Okay. So then I'm not going to do this one because would be similar. It's already, 86, which is 86. It's like a decimal there. So this one you would also subtract zero point 0.5 and add zero point 0.5 to 86. So one decimal place beyond that. Okay, that's the same. But I will do this one. This is tenths, hundreds. So one decimal place beyond the hundreds, tenths, hundreds, is the thousands. So this one has two decimal places. So you want to make use of this one, the three decimal places. Because remember, this says one additional place value beyond what's originally given. So that would be three. So this is going to be equal to 0.43 minus 0.005 and then 0.43 plus 0.005. Okay, and I'll show you the calculator. 0.43 minus 0.005, and that gives you 0.425. Okay, which C matches this here. And then 0.43 plus 0.005 is 0.435. And you see how that matches that right there? Okay. Okay, so that's correct. And then this one is in the 1.6, 1 and 6/10. This is in the tenths place. So 1 decimal place beyond tens, 1 decimal place is 2 decimal places. So that's hundreds. So for this problem, you want to make use of this one, 0.05. 1 decimal place beyond, this is tens, this is hundreds, 1 decimal place beyond that. So this would be 1.6 minus point 0 decimal place beyond that, 1 decimal place beyond that. So we said minus 0.05 and then 1.6 plus 0.05. Okay, so 1.6 minus 0.05, 1.6, and see how that matches, plus 0.05. So you see that? Okay. So that's what we mean by 1 decimal place beyond what was originally given. Okay. Okay, so then these 3 examples down here, this is for more practice to test yourself. Okay. All right. Okay, so look at the 8.4 quarts. See how that's in the tenths place? So you want 1 decimal place beyond that. That's hundredths place. Okay, so this is considered tenths place. Okay, so we're gonna have to use if this is tenths place, you want 1 decimal place beyond that. This is tenths, so you want 1 decimal place beyond that. You want hundredths, so you want subtract and add 0.05 minus and plus 0.05 to this. Okay, so this is 8.4 minus 0.05 and then 8.4 plus 0.05. Okay, so let's see. Excuse me, 8.4 minus 0.05 is 8.35. 8.4 plus 0.05 is 8.45. Okay, so then when I write it up, I'm going to write it up the way they did here, like that, the boundaries. So okay, so this is my work, and then my boundary is going to be you always start with a smaller one first, a smaller one, and then the larger one, and then your units. This is quarts. And I'm not sure again on the computer. You'll have an idea when you do your homework. When you do your homework, when you take your quizzes, right? Your quizzes are going to reflect and be similar to your homework. Okay, and so you want to notice if they make you put in the units or will they already have the units listed. Sometimes they make you choose your units. All right. Okay, the next one, 138. Okay. And so let's go ahead. And this is units for nursing. So I think it's that what is this, millimeters, right? And I think that's mercury, right? And so I'm not sure if that 5 is needed there for that element or not offhand. And I'm sorry, I have to look that up. But this is your units. I'm just not sure if that 5 needs to be there or if that's an error, but I believe that's millimeters for mercury, okay, on the element. And so So let me do the calculation on that. 138. So decimal, and so this is like in the ones place value. So this 8 is in the ones place value. And so you want to use a decimal place, one decimal place value beyond that. So we actually want to use subtracting and adding. And so we want to do one decimal place beyond that. One's place value is a ones place value, then you have tens, ones, and then tens. So you want to use minus and plus 0.5. So this is 138 minus 0.5, 138 plus 0.5. Okay, let me get my calculator. So 138 minus 0.5, 138 plus 0.5. Okay. So 137.5, 138.5. So when I write that up, I'll write the smaller one first, 137.5 to 138.5. And then I'm going to record these units here. And I'll go ahead and put the 5. I'm just not sure if it goes there or not, but I'll go ahead and record that there. But there we have that, okay? All right. Okay, then you see this last one here? 137 and 63 hundredths, okay? So we got these milligrams per deciliters, right? Milligrams per deciliters, okay? So this is 0.63. Notice how that's in the hundredths place, tens, hundredths. So notice how this right here, this 3 is in the hundredths place. So you want to use, remember, one decimal place beyond hundreds, tens, hundreds, thousands. So you actually want to use this one, another extra decimal place beyond what the data was already presented as. So you want to use minus and plus 0.005. Okay, so we have 137.63 minus 0.005. And then we have 137.63 plus 0.005. Okay, and then I'm going to get my calculator. So, and remember, like those of you who are going to be making use of a calculator app, remember you want to keep your app on your flat surface. We don't want to be seeing this like you holding, because you would have a phone app. We don't want to be seeing this like on the screen there. That shouldn't be happening. We don't want the phone, for test security, we don't want that phone being pointed towards the screen. It needs to be on the desktop. And then also, while I'm at it, let me talk about testing. When you're testing, you need to push your either sit like diagonally from your desk. If you have a small desk, sit diagonally. If you're sitting at a big table, you want to push your computer back enough where you can still, get up and type a little bit or type it in and then push that back. But I need to see your paper. You need to angle it and practice that and angle that. But when you're testing, I need to be seeing this down here. I need to be seeing this activity because I'm proctoring and I'm monitoring and reviewing the videos. And oftentimes when I'm grading, I have like two computers open when I'm grading, and I have like shared screen. So I have the actual Canvas test pulled up, your video pulled up, and then your template work pulled up from Canvas. And so as I'm grading, your video's playing the whole time. And it does take me a while to grade. The tests when we take the tests, they're multiple choice, but then I go back and I check the answers. So in order to have the full credit, your work has to support your answer choices, and your work should resemble what I teach you in class. And so, like, if there's any calculator commands, you would write that down. There's formulas, you write down the formula, the substitutions, for the full credit. Okay, but this is not acceptable to be testing. Like when y'all did the practice run, anybody who did the practice run test and is doing this, and I cannot see anything that's going on at the bottom, that's not acceptable. So when you're taking a test, at least for 110 minutes or so when I have your test, that's not acceptable to do 110 minutes of just your face in the camera. No, you need to situate it so that I can see your paper as you're writing and taking the test, okay? So just work with that and set that up so that I can uh, my needs are met, okay? Um, okay, so if I subtract, let me go back and subtract this then. So I have 137.63 minus 0.005. And then 137.63 plus 0.005. Okay. And then when I write that out, smaller one first, then the larger one, and then our units. Okay. All right. All right. So then, so we're on the last part now of 1.2. And let me see your little study guide here. All right. So the boundary, we actually did the boundary, and the boundary was at the bottom. So down here, we just showed you the boundaries. That was 1.2. And then now this is 1.2. We're going to be able to classify the variable as either nominal level, ordinal level, interval level, or racial level measurement. Okay, so leave out that in. And you'll just have two problems like these. They'll appear on the quiz. Okay, these are four levels of measurement, and you're going to have two problems. So again, the computer just randomly pulls from a set of problems. So you don't know, you could be getting two nominal, or you might get one nominal, one ordinal. You could be getting two ratio or one ratio, one interval. You just don't know. The computer's just going to randomly, from the pool of problems, just pick two though, okay? And so just keep that in mind. And then, so then these other ones remaining, when I do another future video, these are going to be covering probably what's left is the 1.3 and the 1.4. So that these are covering that, and you'll see that in a future video recording. Just FYI for your information. Okay, so let's see. We're down to this last remaining page and a half now, because the last page is page 8, and this is the bottom page 7. So as I mentioned, that there's four levels of measurement, and I like to refer to this like as a memory guide, a memory mnemonic guide. I like to refer to this as NOR, and N, because N standing for nominal, O standing for ordinal, I standing for interval, which is on the next page here, interval, and then R standing as ratio. R is ratio. Okay, so we have nominal, categorical, so names. There's no order and there's no ranking. And then they want examples of that. And so before I give you examples, um, let me see, let me share with you a table. Um, you should have access to this table in your Canvas course. You have all your modules. So always read your modules and that will guide you in your Canvas course. Always read the first main module and then that will guide you for the rest of your ideas or content in your course. But we're going over material for quiz 1. So you should have a module that's related to quiz 1 lecture material, quiz 1 material. So in that module, I have a lot of saved past notes, PDFs. And again, the college has recently purchased Zoom. And the price did go up, as I understand it, this semester. They increased the price. But Zoom is a new product, right? And it came in handy just in time. We needed it for what's going on right now with the pandemic. But but I have a lot of safe lecture notes, past notes there. But now that the college has purchased Zoom, so now I'm able to share my videos, make videos, and share them with both now my remote learning classes. They used to be face to face, but because of the social distancing required, they also do remote learning where we meet regularly with the class. And then I have my online. So this is a courtesy. It's a courtesy I'm extending to my online students where before I just had my saved PDF notes and then the ebook. But as a courtesy, I'm recording myself and just me being recorded. When I record in a class and then I post that, it can be distracting because if anybody is not muted, any kind of pages, the camera will turn to them and then you see someone else's picture pop up and things like that. Or there might be not interruptions, but there might be other questions that might be asked. And in a remote learning class, definitely students have the opportunity to ask questions in the class. So definitely encourage that in the remote learning classes, right? But that's the reason why I'm doing just a separate recording so that I don't have, mostly if people forget to mute themselves, or any like distractions, it takes away from the lecture. So this is just the instructor going over the lessons, okay? But anyhow, so I have this flow chart that let me make this smaller, that you should look through in your PDF notes and see, but you should have this related to it. Either it's a separate file or it would be included definitely somewhere in the chapter 1 material, and either probably in the 1.2 because we did 1.1 which was just descriptive and inferential, and then we're in 1.2, so you want to go to your 1.2 um, and read your titles on your PDFs, but you should have access to it. So this is really cool. So I found this on the internet. And this is not in your workbook because these are things sometimes I find extra resources on my own that I have, and it doesn't not everything gets to be inputted in the workbook that we have. But this is a pretty cool little table here, and it says data can be classified as qualitative or quantitative. And y'all did have a table. I mean, there's similar thoughts. Y'all did have a table earlier on page 5. You had this table here on like a flow chart, right? So they have qualitative and quantitative, and then they talk about how quantitative can be broken into discrete or continuous. So you see quantitative is discrete or continuous, but then the workbook's flowchart just stops here. What's really cool about this flowchart is this flowchart continues and it involves the 4 levels of measurement, which is norm. So this is helpful because with NOR, notice nominal is always just qualitative. Um, Ordinal also is just qualitative. Okay, but then when you get to the last 2 measurements, which is intervals and ratio, intervals uh, could be either coming from discrete uh, variables or continuous variables. So remember with discrete and continuous, remember we said that with continuous that you need a measuring tool. So if I go back to, let's see where my notes are for that. Yeah, if I go back to that sheet that had um, continuous and discrete. Remember we said continuous, you would have to have a tool to measure that. Whereas discrete, we had the keyword, the number of, okay? So, so, um, so those in discrete, you could have interval and ratio measurements involved. And also continuous, you could have interval and ratio measurements involved. But that's a good flow chart. So I guess if you wanted, you know what you wanted to do, you wouldn't actually have to print that. Well, actually what we could do to avoid printing extra sheets, what we could do is, I have an idea. What we could just do is add to your workbook. Yeah, because you already have this here, right? So let's see what I could do so that we just fix it on here, add to it. What I could do, maybe change my ink. Let's see. Under qualitative, I could put let me draw this. Let's see. Yeah. So under qualitative, I would have a box for nominal, and then I would have a box for ordinal. Okay, and uh-oh, so let me see. I didn't probably shouldn't have been so quick to write this down. Let me see. I went over ice cream flavors. Okay, so then let me do this. Yeah, and then I put the boxes. You see, these don't have boxes. These are examples of qualitative, but then see, I'm going to put boxes around these. So then these are the levels of measurement. So nominal and ordinal. And that way that matches this. See, so qualitative, nominal, and ordinal. Okay, now I have quantitative, discrete, and continuous. So then discrete, I have interval and ratio. And then for continuous, I have interval and ratio. So I'm going to do that here for discrete. So I have and then I'll do the same thing over here. Yeah, so this says summary data can be classified as qualitative or quantitative. Qualitative data can be classified as nominal or ordinal. Quantitative data can be classified as discrete or continuous, and further as interval or ratio. Yeah. Yeah, so then you don't have to print this extra worksheet, then you just add to that. And what I'm also thinking of doing, now that I'm looking at that, you know how I had little examples here and little examples here. I could probably put some little examples here. See, under continuous. So you see continuous, remember I had some examples, height, weight, temperature, arm span. So, and I know they look, some of them are similar, like because it says weight and we do have weight here. That's true, that will happen. But if I just put some of the ones that I don't already have, and like body temperature, I do have temperature up here, and that's okay. I'll just put arm span, the ones I don't have, and height. Okay, so I have at least some examples protruding out of that. Okay, and then under discrete, I will put, let's see, where do I put it? Maybe here, discrete. And remember, discrete are the ones that have the keywords, number of children, number of books, number of calls, so something like that. So number of books. I guess we could maybe even go this way here. Number of calls. Those are short. Numbers of children, but children is kind of longer. We're gonna have much space. So I'll go with cause. That was one of those are just examples from here. That will help. Okay. All right. Okay. So let's see. Where were we? So back to nominal. Okay, so nominal, categorical names, no order or ranking. Okay. And I'm going to say, and then that's why I'm going to say this here, that data at nominal level are qualitative. So let me go back and see if I have that reflected in my chart. Data at nominal level are qualitative. Yeah, so what I mean by that is if you're nominal and you want to backtrack, it does come from qualitative and not quantitative, but qualitative. That's what that means there. And I have a note that you don't want to use calculations. Okay. All right. So examples would be like zip codes, also gender. And, because it's going back, some of these are going to be repeated. Like we talked about gender and we talked about religion. So those are, and then I have political parties, marital status. Okay, so like single, married, divorce, right? Marital status. Then I have handedness. Some people are either right-handed or left-handed, and then some people are both. What is that word? Axiom. I always have trouble pronouncing that axiom, where they are extradominus where they're both right-handed and left-handed, right? So in statistics, oftentimes they will poll people and they talk about handedness. That's what that means. Um, and then it could also be yes or no responses to surveys. And then also, this is interesting, numbers assigned to runners. So you know how like if people run a marathon, they put a number on them to identify them that way, right? So it's like a name in a sense, right? A name, okay? All right. Okay, so that's the example of nominal. Okay, ordinal. Nominal plus can be ranked, like somehow ordered. Um, and so if I look at my chart on ordinal, let's see. So I have ordinal here, and I have back to qualitative categorical. Okay, that's what the chart reflects. Qualitative. Okay, I'll just keep that in mind. So I don't think I'm gonna write that in there. Um, but I don't think I'm gonna write that in there, but when I have here the examples, so can be ranked or ordered. Nominal plus can be ranked or ordered. Hmm. I don't want to write anything else on there because the thing is when I see this, I'm seeing here can be ranked. So I'm not gonna put a comment on there about that for or no, but I do say nominal plus can be ranked, or shall leave that there. Examples are college class levels. Okay, all right. So college class levels, that would be okay. That would be like freshmen, sophomores. I might have misspelled sophomores. Is there an O there or not in sophomores? Freshmen, sophomores, juniors, seniors. Okay. Yeah, so that's like college class level. Okay. All right. So yeah, because remember, because this went back to or no went back to qualitative. So yeah, so it's freshmen, sophomore, junior, seniors. Okay. And then letter grades. Okay, so letter grades would be like A, B, C, D. Okay, letter grades. So um in this course, of course, you want to aim for best, put your best foot forward and always aim for an A, B, or C. But if a person earns a D, it's my understanding that depending on your program, students could still graduate with a D, but you always want to double check with your advisor and make sure it does depend on the program. And of course, F, no. I guess I should include F's here because that is another grade. But that wouldn't, definitely an F would not qualify for graduation. You would have to retake the class. Okay, but I think with a D, some programs will allow you to graduate with a D. The only thing is that they'll catch you when you transfer over like to the university level. If they notice that that's a flag that they're going to encourage you or they're going to require that you take their stat class there because of the D earned. So that's why you always want to aim for an A, B, or C. Okay, but those are letter grades. So yeah, that's ordinal. Um, let's see. And then sizes. So they have an example here for sizes: small, medium, large, extra large. So there's your sizes right there. Um, but then I also have some extra examples. I have here seat numbers. So for example, let's say A23, A24. So let's say you're sitting on a plane or on a bus, and those would be the seat numbers. Okay. So there is some kind of an order, right? You know, who's sitting by the window, right? For example, so there is some kind of ordering associated with that, right? Okay. And the book also talks about with ordinal, it does say that um, precise differences among the ranks does not exist. So don't do calculations. Yeah. So because if you have see this generic A and B grades, you don't know is the A 95, is the A 90, you know, even 89.5 rounds up to 90, right? So you wouldn't be able to actually do a difference and subtract because you don't exactly, you have a ballpark figure of A is somewhere between 89.5 to 100, but you don't have exact figures, so you wouldn't actually be able to compute a precise difference among these ranks, okay? Among those ranks A, B, C, D, all right? Okay, so that's ordinal. Okay, and then the last page, almost done. Okay. So you see they have a nice little flow chart here that probably was taken, you know, this is, you'll see this, I believe, in your ebook. And so they have different variables. And then they're asking, are they nominal? They start off as nominal, and then are they ordinal? Okay, interval, or are they ratio? Okay. And then you have the level that they finally went with. On the 4 levels, they went with the level of the 4 levels, determine the measurement level, and there's 4 of them. Then they went ahead and concluded level for them, so that you can look at that. Okay, but the last 2 are interval. So interval, they say ordinal plus intervals are consistent. Okay, so I'm going to say here that data is ranked and precise differences and precise uh, differences between the units of measurement exists. Yeah, so here you would have these, you know, exact values, and you could do some subtractions and get these precise differences if you needed to. Let's see. And then going back to the flow chart, let me just see. Interval. So I had a comment here that data are quantitative, or data at quantitative or interval level. So let's see, I think I was trying to word that similar to the way I worded this over here. Let me go back over here and see. I had data at nominal level or qualitative. Okay, so I could say this. I could say data at interval levels. Okay, so I'm saying data at interval levels are quantitative. And then other examples, they have here IQ and temperature. So like an IQ score, I can also put an SAT score or an ACT score. And those scoring systems are different than, it's not out of, you wouldn't be able to put like our tests are out of 100, out of 100. So you wouldn't put that type of a test, but like these specialized tests, IQ scores, SAT score, ACT, that'd be fine. And then it says, there is no true zero. Think about temperature for a minute. Okay. So if you think about temperature for a minute, uh, they say there's no true zero because, you know, if somebody talks about 0 degrees Fahrenheit, if you've taken a chemistry class or physics class, you will learn that 0 degrees Fahrenheit is actually -18 degrees Celsius, or even, I believe, 270 degrees Kelvins. Okay, so that's what they mean by it's not a true zero. Here, when you say zero in temperature, it doesn't really mean zero. It means either measurement in Celsius or Kelvins. Whereas a true zero, which is ratio, so interval says like no true zero exists. Ratio says that a true zero exists. So true zero because if you had $0 in your checking account, let's just say, then that's exactly what that means. That's exactly what that implies. It doesn't imply something else. If they say $0 in a checking account, that's what that means, right? That you have $0. Because um yeah, if you do in the red, like negative values, that means that you actually owe the institution money. So no, this would be an example of a true zero. $0 in a checking account would mean just that you have no money in the account at that time. Whereas 0 degrees Fahrenheit means this. So no true zero exists. The other example of no true zero would be dress size. So let me do this. Excuse me. Let me do this. So let me do this. No true zero. Come back over here. Okay, so another example would be of no true zero would be dress size. So when we think of a young lady's dress size of 0, it 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 doesn't, it means no true zero. It doesn't mean like there's no measurements. Like there are going to be measurements. Dress size of 0 implies this. So on the dress size, there's a bust measurement of 24 inches. There's a waist measurement of 16 inches, and there's also a hip measurement associated with a dress size of 0, which is 27 inches. So there are dress size of 0 means that um, there are associated measurements. Yeah. Okay. So it doesn't mean 0. There's associated measurements related to that. Okay. So that's the interval there. Some examples for interval. And then the last one is oh, and then some of the examples they give for interval, let's see if I can see some here. Yeah, they have temperature. If you look over here, temperature is interval, and that's the only one they have is interval. And the first two we did nor, N and O. So nominal is hair color and zip codes. I had listed zip codes. The hair color I listed on the initial chart, the flow chart. And then also eye color, anything with color, right? We same thing with color. So earlier we had color of uniforms, right? Okay, so then that's nominal on the measurement levels. And then in O, ordinal, so they have pizza sizes. Remember 10 inch, uh, what was it? The sizes for 14 inch. I think it was a 16 inch on the pizza sizes. That's ordinal. Um, excuse me. Ordinal. So yeah, ordinal, is there some kind of ordering, some kind of ranking? Yeah, so the different sizes on those pizzas or sizes. And then NOI. Okay, and last one is ratio. So ratio, they have example of heights and salary here for ratio. And so I have here interval plus ratios are consistent. You have true zeros, and there are meaningful differences between the units. Okay. And so like another example of zero, true zero would be like 0 amps. That means just that. If you have 0 amps like on a battery, that means you have a broken battery. Okay. I also have, excuse me, an example ratio, um, consistent. I have a note here to put example also of pages in 25. I think this is from your ebook. Pages in 25 best-selling novels. So like page 0. So pages in 25 best-selling novels. So they had a reference for some reason. Let's say they had a reference of page 0. Page 0 just means just that, page 0. There's no other meaning behind that. I know it's unusual to have a book with a page 0, but that's besides the point. This page 0 would mean just that. Like, does it mean page 0, or is there some other subtle meaning behind that? So no, that would mean page 0, a book with a page 0 on it. Okay, so that would be ratio. And then I have another example. I have here ages of children at a daycare center. So let me just put this. Excuse me. Ages of children at a daycare center. All right. Okay. And then at the bottom it says test yourself. What level of measurement would be used to measure each variable at the bottom? So the ages, oh, okay. The ages of patients in a local hospital. Okay, so now I see why I put ages of children in a daycare center. See how I had just added that. Ages of children in a daycare center would be ratio, because in the example you have ages of patients in a local hospital, and that would be associated with ratio. So Just an example is like 0. If you had a zero, like a true zero, what would that, what could that mean? Zero, like maybe at birth, you start off right at birth, zero at birth, and then ages, you have years, months, days, hours, and even seconds if you wanted to get into that detail. The ratings of movies released this month. That would be the example of ordinal. Excuse me. Ordinal. Okay. Ratings of movies released this month. Yeah, so some kind of ranking or some kind of order. hmm Yeah, so on the ratings they always talk about too, like how much money they made at the box office, right? This is their information when they release that, right, about the movies. Okay, colors of athletic shirts sold by Oak Park Health Club. So again, colors, that's nominal. Excuse me. And then the last one, temperatures of hot tubs in local health clubs. So that's intervals. We talked about temperatures earlier. It's intervals. Okay. Okay. And then I'll just stop there. This down here at the bottom, they say like classify the examples further, like qualitative or quantitative or discrete or continuous if applicable. And so, but when you take your quizzes, like they're not going to have you classify something and then further like break it down. So when they say qualitative or quantitative, so they're getting that from this qualitative or quantitative, and then discrete or continuous, which you already have those also examples here. Okay, so they're not on the quiz. They're going to just say, is it quantitative or qualitative, right? Or is it discrete or continuous? They're not going to have you within the same problem also break down something else again. Like if it's discrete or continuous, and they're going to say, okay, is that quantitative or qualitative? They're not going to have you go back and break down something else within the same category. Okay, so that's why I'm going to stop there at that point. All right. All right. Hope this was helpful. The idea is to complement those PDFs that are there in your ebook to help you. Okay. All right. Good luck with your studying and your homework that are due related to these sections. Good night, or have a good day.